Now see here, find at least two irrational numbers between 2 and 3. Between 2 and 3, two irrational numbers he is asking. So any irrational number we can write 2.135734336, whatever number you can write. So that is an irrational number only. First here say we should take one square root number and one decimal number. So square root number how to take? So irrational number between 2 and 3 is equal to under root 2 into 3, that is root 6. Root 6 is an irrational number between 2 and 3, and also irrational number, one more irrational number. So in decimal we should take, in decimal, so we should write an irrational number and another irrational number. Another irrational number between 2 and 3 is so 2.50932814003613, so on. It's like this, any number 2.5, here 2.0, 3.0, in between means 2.5. So after that any number you can write. So that is an irrational number. So one irrational number in square root form, so another irrational number in decimal form. So two irrational numbers we can write. Okay. So he is asking two irrational number. So how we took two irrational numbers? So one is in square root according to using the formula under root a into b. So that is square root, and one more so in a decimal form. So one more in decimal form we took irrational number. Okay. Now after that, the ninth question, state whether the following statements are true or false. Justify your answer. Justify your answer. Here justification he is asking. First we should write either it is a statement true or false. He is asking every irrational number is a real number. It is true. True. How it is true? So irrational numbers are real numbers, because rational and irrational numbers are rational and irrational numbers. Numbers are real numbers. Real. All rationals and irrational numbers are real numbers. So that is why every rational number is a real number. Is a real number. Okay. Every rational number is also real number. Irrational number, every irrational number and every irrational number. So that is, this is also true. So why? Because the same statement, all rational and irrational are, all rational and irrational numbers are real numbers. Irrational numbers are real numbers. So that is why it is true. Every rational number, every irrational number is a real number. So both statements are true. Here the third one, every real number need not be a rational number. Yes, this is also true. This is also true. It is not compulsory that every real number is need not be a real number, because in that so irrational numbers are also there, because irrational numbers also real numbers. Irrational numbers also real numbers. So that is why it is not compulsory that every real number is a rational number. So maybe some numbers are real numbers, some numbers are irrational numbers. It is not compulsory that every rational number is a real number. No, it is not compulsory, because rational and irrational combination of both is a real number. Okay. So root n is not irrational. Root n is not irrational. So irrational if n is a perfect square. Yes, it is correct. This is also true. Why it is true? Perfect square numbers are rational numbers. Perfect square roots. Square roots are rational numbers. Which numbers? Rational numbers. So that is why it is true. So it is not a irrational. So it is rational number. The next one, root n is a irrational number if n is not a perfect square. Yes, this is also true. So so the numbers which are not perfect square roots, which are not perfect square roots are irrational. So that is why that is true. All real numbers are irrational. Now, false. So all real numbers are not irrational. Some are rational and irrational. Rational and irrational are real numbers. So justification. What is justification? Rational and irrational. Numbers are real numbers. Real numbers. Rational and irrational numbers are real numbers. Okay, students, this is the answers. So first we should decide either it is true or false. Then after that, justify your answer also. How your answer is true, how your answer is false. Either your answer is true, why it is true. If your answer is false, why your answer is false. Just that justification also he need. Okay. Okay, students. See here, locate root 10 on a number line. How to locate root 10 on a number line? So first we should draw a number line. So with a scale. So draw line with a scale with the help of a ruler. So with the help of a ruler, draw one straight line. So then after that, so draw 0 in the middle. 0 in the middle. So then take 1 centimeter and mark numbers on the number line. 1 centimeter. On each centimeter, so mark a point. So on each 1 centimeter, take 1 centimeter distance and mark sub numbers. Mark your numbers. So here. Here 1, 2, 3, 4, -1, -2, -3 and -4. So take 1 centimeter gap on each number. So then after that, so root 10, how to mark root 10 on a number line? So root 10 nearest square root is 9. 9 9s are, means 3 3s are 9. 3 3s are 9 means 9. If square root 9 is square root 9, what is the square root 9? 3. So square root 9 is 3. So here to here, so 3, and after that you take 1 centimeter above 3 perpendicularly. Draw 1 centimeter perpendicularly from 3. Okay. So this here you should draw 3. Here on 3 you mark a point. So here a point is O, here a point B, OA. So this is a point A. And join, so A, and this is the point B. So this is the point B, OAB. Now join OB. Now join OB. joined OB. OB. This is OAB is a right angle triangle. So, take a point, we know that root 9 is equal to 3. So, which is near to which is near to root 10. Then, so mark a point, mark points O at 0, A at 3 and AB length is 1 unit, that is 1 centimeter. Here it is 1 unit. OAB is a right angle triangle. OAB is right angle triangle. Right angle triangle. So, then we know that OB square. So, this is slant square is equal to sum of the sides of two perpendicular, sum of the squares of two perpendicular sides, that is OA square plus AB square. OA is 3 square and AB is 1. 3 square is 9 and 1 square is 1. 9 plus 1 10, that is OB square. Then OB is equal to root 10. So, what is OB? Root 10. Now, after that what we should do? So, with the help of compass, O as a center, OB as a radius. O as a center, OB as a radius. So, draw an arc, draw an arc. O as a center, OB as a radius. Draw an arc which cuts OB here. This is, so which cuts OB here, OAB here. This is point C. So, beside A, it will cut beside A, that is C point. From O to C, from here O to, from here C point, the distance is root 10 units, root 10 units. So, this is represent 10, square root 10. Okay, in this way, so we draw square root 10 on a number line, Okay, students. Now, so here, so the next topic, so in this, so constructing square root spiral. So, then how to construct square root spiral? See here, first with the help of a scale, we should take 1 centimeter first. 1 centimeter, draw 1 centimeter. So, like this, you should draw 1 centimeter. So, this is 1 centimeter line segment. So, that you take OP. So, this is O and this is P. OP is 1 centimeter. So, again from P, so we should take a perpendicular, line, we should take one perpendicular line which is 90 degrees. So, here 90 degrees. So, mark a point, so which is 90 degrees. So, from here, so here to here, so join this line like this, and here you take 1 centimeter. So, O to Q. So, here remaining you should rub it. So, only 1 centimeter perpendicular line we need, this is Q. So, now join OQ. What is OQ? So, what is OQ here? See, this is right angle triangle. So, we know that we took OP as 1 unit and OQ as 1 unit, that is 1 centimeter. So, OPQ is right angle triangle, OP is equal to 1 unit, OP is equal to OQ is equal to 1 unit, 1 unit from, so right angle triangle, from right angle triangle OPQ. So, OQ square hypotenuse square is equal to sum of the squares of two perpendicular sides, that is OP square plus PQ square. OP square is 1 square, PQ square is 1 square, 1 square is 1 and 1 square is 1, 1 plus 1 is 2, OQ square is equal to 2, OQ is equal to square root 2, OQ is equal to square root 2. What is OQ? OQ is equal to square root 2. So, what is OQ? That is square root 2. So, this is square root 2. So, then after that again OQ as a base. So, OQ as a base, draw a perpendicular, draw one perpendicular line. So, then from here draw a perpendicular line. Now, OQ is perpendicular, OQ is, so OQ, OP and one more line. So, here we need only 1 centimeter, from O to 1 centimeter only we need. So, till mark a point at 1 centimeter and remaining line segment rub it, rub the remaining one. So, then this is R. Then OQ is equal to root 2 units and QR is 1 unit. QR is equal to 1 unit. This is 1 unit. Now you joined OR. Now you join OR. Now, so after that OQR, OR is equal to, OR is perpendicular to OQ, OR, this is not OR, OQ is perpendicular to QR, OQ is perpendicular to QR, OQ is perpendicular to QR. Now, so OQ, that implies OQ is equal to root 2 units and QR is equal to 1 unit. So, OQR from right angle triangle, from triangle OQR, OQR is a right angle triangle. So, that is OR, OR square is equal to OQ square plus QR square, QR square. Then OQ, what is OQ? OQ is root 2, root 2 square plus QR, QR is 1 square, root 2 square means 2, 2 plus 1 square is 1, 2 plus 1 3, this is OR square. Then OR is equal to square will get root, that is root 3. So, OR value is root 3. So, OR is, this is root 2, this is root 3. Then after that, so again OR as a base with the help of a protractor. So, draw a perpendicular line, draw one perpendicular line from O point, point O. Here mark a point and draw a perpendicular. So, like this. We should draw a perpendicular like this. Then after that, take 1 centimeter from point O, only 1 centimeter we need, 1 centimeter. With the help of a scale, at 1 centimeter mark a point. So, remaining, so rub it. So, this is S. Now, RS is 1 unit, RS is 1 unit. Now, you join OS, now you join OS. So now again OS here, SR OR perpendicular, SR, so SR OR is perpendicular to SR, then from triangle, then OR is equal to OR length. What is OR length? Root 3. Then RS is 1, RS or SR is equal to 1 unit. From triangle ORS, from triangle ORS, so OS square is equal to sum of the squares of two perpendicular sides, that is OS square plus RS square, OR square, that is OR square. So this is OR square plus RS square. OR, what is OR? OR is root 3 square plus RS, R to S, that is 1 unit, 1 square, root 3 square, square root will get cancelled, 3 plus 1, 3 plus 1 is 4, OS square is equal to 4, OS is equal to root 4, root 4 answer is 2. So then what is OS? It is root 4, it is root 4, root 4 is equal to 2. So then after that again, so OS as a base, OS as a base, again draw a perpendicular 90 degrees. So now O to S, draw a perpendicular. So now after that O to S, from S as a center take 1 centimeter and there you mark a point T. So then after that join OT and find, so according to the triangle OST you will get OT as root 5 and continues this. So you will get root 2, root 3, root 4, root 5, root 6, root 7, root 8, root 9, root 10, like this spiral you will get. Okay, one by one first. So this triangle, from this triangle you will get root 2 and after this from this triangle you will get root 3, from this triangle you will get root 4 and again from this triangle you will get root 5, root 6, root 7, root 8, root 9, that spiral we will get one by one the spirals we will get. So square root values, that is irrational numbers we are getting. Okay, okay students. So now the students, the next concept, representing real numbers on the number line through successive magnification. So successive magnification, so then how to locate on a number line. See here, so here given question is 2.776. This 2.776 we should locate on a number line. Then how should we locate on a number line? Here 2.7, first 2 point is given, 2 given means it is in between 2 and 3. First we should draw a number line. So like this, here you should take 2, here you should take 3, here we have 2, here 3. So 2.7, first we should locate 2.7 first. 2.7, where the 2.7? So first 2.2, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9, 2.8, here 2.8, 2.9 and 3. So now here this is our 2.1, after that 2.2, now here 2.3, now 2.4, now 2.5, now 2.6, now 2.7, now 2.8, 2.9, 3. So 2.7. So the first decimal we locate 2.7, 2.7 and 7, 2.77. 2.77 is in between 2.7 and 2.8. 2.77 is in between 2.7 and 2.8. Here 2.7 is there. So, here we have 2.77 in between these two. In between these two we have 2.7 and 2.8. So, 2.77, so we have in between 2.7 and 2.8. Again you draw a number line. So, from here it is from 2.7, here 2.7, here we should take 2.8. So, the number 2.77 is in between 2.71, 2.72, 2.73, 2.74, 2.75, 2.76, 2.77, 2.78, 2.79, 2.8. Here 2.71 will come here, 2.72, 2.73, 2.74, 2.75, 2.76, 2.77, 2.78, 2.79, 2.8. Now, so first we should look at single digit, tens digit, then 2.77 double digit. Here this is till 2.7 we locate. So, then 2.77 is 2.7 is in between 2 to 3. It is in between 2 to 3. 2.77 is in between 2.7 to 2.8. 2.7 to 2.7 to 2.8. Here we have 2.77. 776 is there. So, 776 means 776 is in between 77 and 78. So, 776, 2.776 is in between 2.77 and 2.78. So, now again we should take a number line. Now, so our number is 2.77, 2.77, 2.78. Now, 2.71 first, 2.771, 772, 773, 774, 775, 776, 778, 776, 777, 778, 779. Now, first 2.771, 2.772, 2.773, 2.774, 2.775, 2.776, 2.777, 2.778, 2.779, 2.780. 780 means 780. So, now what is our answer? 2.776. Where is 2.776? This is our 2.776. This is the point 2.776. In this way we should look at, first we should look at 2.7, where it is 2.7 is in between 2.7 and 2.8. After that we should zoom it like this. If you zoom it, then you will get 2.7 and 2.8. In between 2.7 and between 2.8 you will get 2.77. Like 2.7 means 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 80. So, now we need 776, 77, here 77, 78, in between 77 and 78, in between 77, in between 78, 2.77, 2.78, 770, 771, 771, 772, 773, 774, 775, 776, 777, 778, 779, 780. So, here we have 2.776. Okay. So, 2.776 is in between 2.77 to 2.80, 2.78, not 80, 2.78. So, 2.776 is in between 2.77 to 2.78. So, 77 means 770, 780, 771, 772, 773, 774, 775, 776, 777, 778, 779, 780, 780 means 78 only, 2.78. So, like that we should zoom and zoom. First we should zoom, so that is in between 2 and 3. After again if you zoom in between, so then you will get this. Again if you zoom it, then you will get this one. Okay. So like this we should find, so we should locate our decimal number on a number line, First single digit we should locate, after that double digit we should locate, after that triple digit we should locate on a number line. Okay. Okay students. So now the next question, visualize the representation of 3.58 bar on the number line through successive magnification up to 4 decimal places. How many decimal places? Up to 4 decimal places we need. So that is decimal is 3.58 bar is given. So what is 3.58 bar? 3.58 bar, it means 3.5, so bar is on 8. So it means 8 repeats infinite times, 8, 8, 8, 8, 8, so on. So 3.588888 up to infinite times, up to 4 decimal places. 4 decimal places we need. How many decimal places? 4 decimal places. So here 3 point up to 3 decimal places we should take as it is 3.588. Up to 3 decimal places we should take as it is, that is 3.588. This is our 4th decimal place. So after decimal 1, 2, 3, this is the 4th decimal. 4th decimal is 8. So then what we should take 4th decimal? For 4th decimal, so we should check what is the 5th decimal. So what is the 5th decimal? So if our 5th decimal is 5 or more than 5, if our 5th decimal is 5 or more than 5, so then we should increase 1 here. If it is less than 5 means 1 to 4, so then we keep as it is. Here the 5th decimal place is 8. What is the 5th decimal place? 8. So that is why the 4th decimal we should take 9, means we should increase 1. 8 plus 1 is 9. So like this we should decide our 4th decimal place. How to decide our 4th decimal place? For deciding 4th decimal place, we should check 5th decimal place. So if in the 5th decimal place, if it is 5 or more than 5, so we should increase 1 in 4th decimal place. If 8 is there, so we make it as 9. If 4 is there, we make it 5. If 2 is there, we make it 3. If 3 is there, we make it 4. Like that we should increase 1. When? If 5th decimal place is more than 5 or more than 5. If it is less than 5, we should keep as it is only. So how to adjust? This is the adjustment up to 4 decimal places. Now after that visualize. So visualize, how to visualize? First 3.5 till one place of the decimal we should visualize on a number line. 3.5 is in between 3 and 4. So first we should draw a number line like this. Here 4 and here 3. So 3.5 is in between 3 and 4. So you should take 3 here. This is 3.1, 3.2, 3.3, 3.4. This is 3.5, 3.6, 3.7, 3.8, 3.9, and this is 4. So this one is 4. Okay. This is 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.7, 3.8, 3.9, 4. 4 means 4.0. So 3.5, where is 3.5? Here this is 3.5. 3.5. So we should take now 3 digits. 3.5 is in between. 3.5 is between 3 and 4. 3.5 is in between 3 and 4. Now we should take 2 decimal places, 3.58, 3.58, 3.58. 3.58 is in between 3.5 and 3.6, 3.5 and 3.6. First we should zoom it to get 3.5. So 3.5 here you will get. Again 3.58, where you will get? So if you zoom here 3.5 to 3.6, then you will get 3.58, 3.58. It means the 3.58 is in between 3.58. 3.58 is between 3.5 and 3.6. 3.5 means 3.50, 3.60. So there is no means 3.50 first here, 3.5 here, 3.6, 3.50, 3.51, 3.52, 3.53, 3.54, 3.55, 3.56, 3.57, 3.58, 3.59, 3.59, then 3.6 means 60, 3.51, 3.52, 3.53, 3.54, 3.55, 3.56, 3.57, 3.58, 3.59, 3.60 means 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60 like that. So 3.58. So 3.58. So here we have 3.58. Now after that 3.588 we need 88. 3.588. Where is 3.588? 3.588 is in between 3.588 and 3.59. So if you zoom here, then you will get 3.588 in between these two values. First 3.5 and in between 3.5 and 3.6, in between these two values you will get 3.58. 3.5 and 3.6, in between this you will get 3.58. 3.58. Now, so 3.588 we want. Three point five eight to 3.59. You will get 3.588 is between 3.58 to 3.59. 3.580, 581, 582, 583, 584, 585, 586, 587, 588, 589, 59. So here 581, 3.581, 3.582, 3.583, 3.584, 3.585, 3.586, 3.587, 3.588, 3.589, 3.589, then after that 3.590, 590, 580, 581, 582, 583, 584, 585, 586, 587, 588, 589, 590, 590. So it means 3.58 and 3.59, in between you will get. So 3.588, 3.588, here 3.588. So here 3.588. Now we need 3.5889, 3.5889. So again 3.5889, 3.5889, 3.588, 3.5889 is in between these two values, 3.588 and 3.5889. So in between you will get 3.5. Now 3.5889 is between 3.588 to 3.589, 589, 3.588 589, this is 8, this is 589. Now here 3.588, here 3.589, 588, 3.5881, 5881, 3.5882, 3.5883, 3.5884, 3.5885, this is big one, 3.5886, 3.5887, 3.5888, so 3.5889, then 3. So take here, so 3.5890, 90 means 9 is enough. Now actually, so we don't read like that 5881, so that is not actually method. So 3.88, 3.588, 3.5881, 3.5882, 3.5883, 3.5884, 3.5885, 3.5886, 3.5887, 3.5888, 3.5889, 3.588, so 9, 3.59 here, 589, 59, 0, 90, that is 589, 5889, 589. So then what we need, 3.5889, 3.589. So this is actual location, 3.589. First we should look at 3.5. 3.5, where is the 3.5? In between 3 and 4, here 3.5. 3.5, 3.58 we need, 3.58, 3.58 is in between 3.5 and 3.6, it means 3.5 to 3.6, 3.51, 52, 53, 54, 55, 56, 57, 58, 59, so 3.60. So then 58 to 59, 58, 3.58, so the second, so here 58, we need 588, 588 is in between these two, 3.58, 3.59, 581, 582, 583, 584, 585, 3.588 you will get here. So now we need 3.8884, 3.884 in between 3.588 to 3.589. So then, so where it is exactly here. So step by step we should go. First, so decimal 1 place, then 2 places, then 3 places, then 4 places. How many places we need, that many number lines we should draw and say exact where the decimal point will come. Okay, that we should represent on number line. Now visualize 2.874 on the number line using successive magnification. First 2.874, first 2.8. So where the 2.8, first we should locate that one. 2.8 is in between 2 to 3, in between 2 to 3. So here this is the number line. Here we have 2, 2.1, 2.2, 2.3, 2.4, 2.5, 2.6, 2.7, 2.8, 2.9, 3. Here 2, here 3, here this is 2.1, here 2.2, this is 2.3, 2.4, then 2.5, next 2.6, 2.7, 2.8, 2.9 and 3. So here 2.8, so till 2.8 is over, now 2.87. So 2.8, where is 2.7, 2.8 here, 2.8, here 2.8, 2.87 is in between 2.8 and 2.9. So here we have 2.87. So now another number line. So the next, here the first we should take 2.8, 2.8, 2.81, 2.82, 2.83, 2.84, 2.85, 2.86, 2.87, 2.88, 2.89, so 2.9. So, here 2.8, 2.81, 2.82, 2.83, 2.84, 2.85, 2.86, 2.87, 2.88, 2.89, 2.9. Here we should write. So, 2.8 is between 2 and 3. Next, after that 2.87. 2.87 is between 2.8 and 2.9. So, 2.87 is between 2.87 is between 2.8 and 2.9. Here 2.87 is here. 2.87, now we need 2.874, 2.874, 3 digits. 2.874 is in between 2.7 and 2.87 and 2.88. In between we have. So now we should take a number line again. Now here 2.874 is between 2.87 and 2.88. So first 2.87, here 2.88, 2.87, 2.871, 2.872, 2.873, 2.874, 2.875, 2.876, 2.877, 2.878, 2.879, 2.880. Now, here 2.871, 2.872, 2.873, 2.874, 2.875, 2.876, 2.877, 2.878, 2.879, 2.88. Now, here what we need? 2.874. Where is 2.874? Here. 2.874. So, this is the location. This is the visualizing location. Okay. First, we should find where the number lies between. According to that, we should write a number line and check where it is. So, if 3 digits are there in the 3 steps, it will complete. If 4 digits were there, it will complete in 4 steps. Okay. The second question, visualize 5.28, 5.28 bar. So, bar is on 8. So, on the number line up to 3 decimal places, Now, here solution, how to visualize, see here. So, 5.28 bar, that means 5.288888, it will continue infinite times. 8 will continue infinite times. Why? Bar is on 8. Then, first on up to 3 decimal places, how many decimal places? 3 decimal places. Up to 2 decimal places, we should keep as it is, 5.28. 5.28. So, for the third place, we should check fourth place. So, what about the fourth place? Fourth place is more than 5. If fourth place is more than 5, 5 or more than 5, we should increase 1. So, here 8 is there, we should take 9. Okay. So, for third place, for fixing third place, we should check fourth place. If fourth place is 5 or more than 5, we should increase 1, whatever is there in third place. Okay. Now, so that means we should visualize 5.289 on number line. So, how to visualize? First, 5.2 till 5.2 we should visualize on number line. 5.2 is in between 5 and 6, 5 and 6. Now, draw number line here. 5.5 So, and here 6, 5, 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, 5.9 and here 6. Here, so right here 5.2 is between, so 5 and 6, 5 and 6. So then 5, this is 5.1, this is 5.2, this is 5.3, 5.4, 5.5. Then here 5.6, 5.7, 5.8, 5.9 and 6. Now after that, so 5.2, here 5.2, 5.2 is here 5.28. So till here we should check 5.28 is in between 5.2 and 5.3, 5.2 and 5.3. So now in the next number line we should take here 5.2, 5.21, 5.22, 5.23, 5.24, 5.25, 5.26, 5.27, 5.28, 5.29, 5.3, here 5.2. So what we need? 5.28. 5.28 is between 5.2 and 5.3. 5.2, 5.21, 5.22, 5.23, 5.24, 5.25, 5.26, 5.27, 5.28, 5.29, 6. Okay, 5.28. Now what we need? 5.28. Where is 5.28? Here we have 5.28. So now we need 5.289. Now 5.289 is in between 5.28 and 5.29. 5.28 and 5.29 in between we have. So in the next one 5.28, 5.289, 5.289 is between 5.28 and 5.29. So it is in between 5.28 to 5.29. Here first one 5.28, 5.28, 5.281, 5.282, 5.283, 5.284, 5.285, 5.285, 5.286, 5.287, 5.288, 5.289, 5.29, 5.29 here. Here we have 5.29. Now 5.289. Where is 5.289? Here we have 5.289. So this is our location. This is our location. So one by one, first single digit we should locate. After that double digit we should locate. After that triple digit we should locate. Okay. One by one we should visualize on number line. Okay students.